All right, so again, carrying on with our fuel injection diagnostic trouble code listings here. Our next series here is the P112 and P113 diagnostic trouble codes. So what that entails is the manifold air temperature sensor itself. So kind of to break apart what we're going to do here, I'm going to tell you a little bit about what the MAT sensor does, where it's located. Then we're going to dive into the physical troubleshooting element of it, checking the circuits and so forth, and then the new element of this that we'll do is we'll incorporate the laptop software, and I'll show you how to do the diagnosis using the laptop software as well. So let's begin. Now, the manifold air temperature sensor, if you remember back a couple of sessions ago where we talked about the manifold air pressure sensor, or MAP sensor. Now, it's a sensor that is a combination piece here. There is the MAP part of it, which monitors manifold vacuum. And then there's also a thermistor built in that drops down into the intake runner that measures the incoming intake air temperature. Now, the reason why we need to measure that is because that's really our gauge on air density. Because if relative to what air temperature is doing, there may be less than or more than a certain oxygen content level. And sometimes we need to make on-the-fly changes to the calibration to compensate for that. So for example, as we get hotter temperatures outside, there is typically less oxygen content. So usually we end up having to trim back a little bit of fuel so the engine doesn't run excessively rich. And then we sometimes have to bring back ignition timing events because the hotter air is a little more unstable, and we could run into issues with abnormal combustion events like detonation a little bit easier. So we usually have to remove a little bit of ignition timing advance to keep the engine safe. So it's all about trying to keep the engine optimal to a sweet spot of operation, of course, for the given conditions. Now, the inverse of that, when we go colder, now there's more oxygen content available. We can add a little bit more fuel to match that, and then sometimes we can ramp in a little bit more ignition timing advance for a little more of a power yield there as well. So, how we begin to troubleshoot this is just like anything else. We have to read and verify whether we have a code present. Okay, so the first step here is we're going to do it the longhand way here, and we're going to read it with a tiny scan, measure out some of the circuits at the sensor itself, and then of course look at the laptop. So what I'm going to do first here is I'm going to turn the ignition on, take my tiny scan, and I'm going to read the codes here with our diagnostic data link connector here. So take a look here. We got two codes available at this particular time. I have a 107 and 108. Now, remembering with the tiny scan, it cannot tell the difference between a current and historical code. So what I'm going to do here is clear the codes and then read them again. Whatever comes back is now current. So let's go through that process here. So now I'm at the end of the codes here. It's asking me to hit clear. I'm going to press the button one more time and hold it. All right, done. I can let go of the button. Now it will reread. It should tell me how many codes I have left. I have one. P0113. All right, so just like every other code here, there's typically a high and low voltage here. So the 113 indicates a high voltage is seen here, meaning the fact that we're seeing 5 volts returned on our signal wire back for that temperature sensor. How it works really is there's 5 volts from the reference circuit that goes through the resistance of the thermistor. And of course, as the thermistor reports a different temperature change, really what's happening is the resistance varies, which basically affects a voltage drop coming back to the computer. So we send 5 volts into it, and it needs to operate within this range of 0.5 all the way up to 4.5 volts, anywhere in that window. Now, what it's telling us right now is we've stepped above 4.5 volts on the return side. And when we test this out here, we'll be able to verify that. So first things first here is we got to take some measurements using the back probe pins and a voltmeter at the sensor itself. So first thing I'm going to do here is I'm going to take my red wire with a white stripe right here. I'm going to back probe that one, and then I'm going to hook that alligator clip up to my red meter lead. That way I can begin a test here of testing our 5 volt reference circuit right up front. Now, it's probably working okay, seeing as it produced the code for us, but we want to always verify. The next thing I'm going to do is I'm going to back probe the dark brown wire on the edge over here. It's the dark brown one, not to be confused with the tan one, dark brown. That way I complete my circuit here, hook that one up to my black meter lead, And then I'm going to turn my meter on. Now when I turn the meter on, I should see almost 5 volts, and I do, which is good. That tells us that we have 5 volt reference there. Now, the way to test this a little bit further is just make one strategic move here. This yellow back pin that I have in the red wire with the white stripe, I'm going to move it over next door to the tan wire with a black stripe. That is our signal wire back to the ECM, telling us what the temperature is coming out of that sensor. Now remember, the P113 code that we saw indicated high voltage. So let's take a look at what the meter shows us right now. I see 4.9 volts. It's exactly what the meter is trying, or what the code is trying to tell us right now, that we are in a high voltage situation. Okay, there's not enough resistance to pull the voltage down to what it thinks is normal. Now the inverse of this would mean that you have too much resistance, right? You would be seeing a P112, which indicates low voltage, so we would be below a threshold. There could be corrosion in the wires. There could be some sort of extra resistance that's killing off some of the voltage on the return path. It's either going to be internal to the sensor itself. We can't take it apart. We can't look at it. We can't repair that. All we can do is verify the circuitry to and from is intact and working. Now, what you can do here to kind of verify everything else is good is you would look at the terminals here themselves. You would take this little blue locking clip off here. I'll demonstrate for you. Remove this. It's a little tricky here. You got to get it. There we go. And I can see that all of my terminals are at the same height here. So I'm okay there. Again, you could take it a step further and then look at whether we have wiring or the terminal itself has actually crimped the copper wire. I would argue that it is okay because the computer is seeing the difference there. Okay. Also, you want to verify your map sensor pins, make sure they're all there. Everything looks okay with this one. So I'll go ahead and reconnect it again. All right. So at this point, what we would end up doing here is really just replacing the map sensor because we did a scientific test here. We basically proved everything else but the sensor seems to be working correctly. Now the default operation of this is when the engine goes into what they call limp mode here, or a default operation, when we can't rely on this sensor to give us an accurate temperature input, it just defaults to the engine head temperature. So it basically will mirror exactly what the head temperature is telling us, and it gives us another thermal input here for that circuit to run. So this is one code that probably won't produce much of a performance loss, or at least a noticeable one, because it has something else of nearly equal value to fall back on. There's maybe only about 30 degrees difference between the two on a normally functioning engine, so it's not a giant impact to performance. So now let's take a look at how we would troubleshoot this using the laptop software. Okay, to start with, I need to go ahead and plug in my laptop software to the board, or my engine, and I'm going to go ahead and do that now. I got to go up here and I got to connect it where it says online. I'll click this. It'll go through its routine, do its little checks, and then just hit OK through the things that it's telling me about. And you can see right here it's telling me, hey, you have diagnostic code P113. By the way, if you want service manual information, all you have to do is click on this and it opens right to the page in the service manual. It's basically just opens a PDF. Gives you all your circuit description, how the thing works, and of course your flow chart, how to troubleshoot it. Basically just what I'm telling you here, only in video format. Okay? Now, let's go out here to the dashboard and look at what we got. Now, I'm connected here. Even when my engine is actually running, we can see that our RPMs are reading, and you notice that the temperature inputs now, engine head and manifold air temperature, are pretty much reporting the same. Okay? Now, with this being said here, we would look at the sensors tab for the dashboard over here. So I would look at this, and I would look at my mat sensor actual voltage being returned. You notice it says 5.0 volts here right now. Okay, that's again confirming what we saw on the with the voltmeter itself and doing the physical test. So again, let's go back to the laptop here. I'll show you something else here. Again, this is under dashboards and sensors here. So this is where you look at all your raw data here. So coming out of here, it's reporting that we have 73.6 degrees or so, which is exactly what engine head temperature reports. You got 5.0 volts. Normally this would be below 4.5. You notice that right now our engine head temperature is reporting 4.2. And of course there's the metric centigrade version there as well. This is the tab where you would look at all your basic voltage inputs for most of your sensors at right here. This bypasses the need to do a test with the digital voltometer. So that pretty much concludes how to actually do this test with two different methods now. So with that being said, we can move to questions. All right, welcome to our first question and answer session here. All right, our first question comes from Larry in Colorado. He asks, a future program concerning the connection of an engine trouble light would be helpful. Larry, I think you're referring to the malfunction indicator light or a service engine soon light for this thing. That would actually be a really good exercise, and it is a pretty easy process to do. Really, you're just hooking up power to a light bulb, and then the ECM runs the ground there. But yes, we'll definitely make that a consideration for our upcoming events here, in terms of probably covering more of a heavy troubleshooting aspect when it comes to repowering these machines with an EFI engine, or just general questions involving repower with an EFI engine. All right, that appears that's all of our questions for this week. Again, thank you for taking the time this afternoon to be with us, and we look forward to seeing you again next week. Thank you.